Hi, welcome to another episode of Fluid Mechanics, and I'm your host, Arid Wire. So, let's start off by asking the big question. What is viscosity? Viscosity is a measure of resistance of a fluid which is being deformed by either shear stress or tensile stress. For fluids, only may be called thickness or internal friction. One may see it as understanding viscosity as how thick a substance actually is. This is called Newtonian's law of viscosity, and fluids that obey it are said to be Newtonian. It describes how easily a fluid flows. The viscosity mu is sometimes called the dynamic viscosity, as this differentiates it from the kinematic viscosity, which is the dynamic viscosity divided by the fluid density. Now, we said earlier that the fluids that obey Newton's law of viscosity are said to be Newtonian. The shear stress increases linearly with the strain rate. But for fluids, the relationship between shear stress and strain rate is nonlinear. These are called non-Newtonian fluids, and there are two main types: shear thickening fluids and shear thinning fluids. For shear thickening fluids, the apparent viscosity increases as the strain rate increases, and for shear thinning fluids, that apparent viscosity reduces as the strain rate increases. As an example, paint. Paint is an example of shear thinning fluids. It's easily applied with the brush but doesn't drip from the wall once it is applied. For this experiment, you will need white copy paper, a ruler, a pen, tape, scissors, shot glasses or souffle cups, a baking sheet pan, and plastic wrap. A few other materials that you may need will be water, corn syrup, vinegar, olive oil, vegetable oil, honey, alcohol, syrup, and Dawn dish detergent soap. Here's an example of how you should wrap, tape, and apply your paper to the sheet pan. First, start by grabbing a piece of paper and marking a finish line. Then, tape the piece of paper to the back of the sheet pan. Next, grab the plastic wrap and tape all four sides of the pan to the plastic wrap. Be sure to not poke any holes in the plastic wrap, or it will destroy your finish line and your paper. So, now that we have everything completed, let's see the results. As you can see, water, alcohol, and vegetable oil have a very low viscosity and a high flow rate. And this is because cohesive forces. Cohesive forces is basically how fast a particle moves past each other. Here you can see a medium viscosity. This is corn syrup, dish soap, and olive oil. This means it has a moderate viscosity and a moderate flow rate. Now, maple syrup and honey, on the other hand, have a very high viscosity and a low flow rate. So, for the time results, water wins at 0.23 seconds. Then, dish soap wins at 3.76 seconds. And lastly, we have room temperature maple syrup winning at 8.85 seconds. So, to better explain how cohesive forces affect viscosity, it's usually a fluid such as honey has a high viscosity but a low flow rate. But what if we add temperature to the equation? Increasing the temperature will usually create a lower viscosity and a higher flow rate. So, in closing, we compared hot syrup to cold syrup. Hot syrup wins. When increasing temperature, viscosity lowers and flow rate increases. So, thank you guys again. Make sure to like, subscribe, and share.